So when you talk about OS deployment, or Windows 10 deployment in particular, there are many challenges. Some of these challenges are related to getting the image ready, injecting drivers, making task sequences, all the variables. And there are many sessions that are focused on those aspects and those challenges of Windows 10 deployment. This is not what we're going to talk about. What we are going to talk about is, once you have learned to make task sequences and nail down all those technologies and problems and learning experiences, what then? How are you going to get this thing out on a massive scale in your production networks in a short period of time? We're going to use, as an example, one of our larger deployments. It's a bank, 300,000 computers, 10,000 locations in 100 countries. When we first started talking to them, they had a 5-year project to enable Pixie in 100 countries, speaking French, German, Portuguese. It's a major task. We were able to enable Pixie in 5 minutes on that network. So we're going to talk about some of those experiences. Not everybody here will have 300,000 machines to manage. But the problems that those environments face are the same problems that each one of us faces in production, because this is a very difficult thing to do. So I'm going to take you into a very different presentation. I have only 2 slides to show, but I have a lot of software and technology to show you. And we are going to actually build a machine using some very innovative technologies. Just a couple of words about my employer, Adaptiva. We are located in Bellevue, Washington, just a few miles from Redmond, where our favorite company is based. We have become known for winning a lot of awards for innovation. There's a lot of cool technology that comes out of Adaptiva. We've been keeping a low profile, except for the last couple of years. So many of you have heard of us, and some of you haven't. The Red Herring Award, the Stevie, some of these are very big awards, network products. It's very unusual for a single company to keep winning these every year. And I'll show you some of the cool things we have done that make us win these. My background, my name is Deepak. It'll come up in the next slide. I lead engineering at Adaptiva. Before Adaptiva, I was one of the designers on the SCCM product team and won several patents there, and then chose to continue to innovate in System Center outside of Microsoft. So we are great partners. We maintain good relationships professionally, personally with the development team there. Deployment challenges for massive scale. Before massive scale, there are many challenges. Getting the image ready, getting the drivers injected. I'm assuming that everyone here knows already how to do that. And those are solved problems. What are the real challenges? Based on the experiences I've had with more than 100 customers, with very, very difficult environments. One of you here told me yesterday, they actually built a machine in Liberia. I don't even know where that is. Okay. So what do they do to solve these challenges? I'll just quickly, this is one of my 2 slides. 4 challenges. Pixie. Enabling Pixie on this network, which is very real, 100 countries. You need servers everywhere. You need router configurations. The networking team is not going to give you router configuration changes. They don't even know where the routers are. Thousands of routers. You need IP helpers. You need DHCP scope options. Now, good luck if your DHCP is running on a Cisco router. So this is one of the bigger challenges that you don't really control. I'm going to show you peer-to-peer Pixie. No servers, no IP helpers, no router configuration. You will own the Pixie infrastructure, not your networking team. The second is content distribution. If you're doing your image right, it is unlikely that it's going to be smaller than 20 gigs. You need a lot of drivers, a lot of applications. It'll be fully patched. How do you get it out there? How do you get it to Liberia? Or, one of you who's here deployed a 20 gig image to China during the POC. One of you here is doing OST in Botswana. That's the second challenge. Huge content, narrowband pipes, how do you get it out there? The third is user state migration. People have a lot of stuff on their computers. You don't know how much it is. Getting it backed up across the WAN, building the machine and getting it back down is not a practical option. If you have a location with 5, 10, 20 machines, how are you going to do OSD without destroying the user's years and years of work and settings and making them really mad at you? That's the third challenge. The fourth is version control. This was interesting. This came from people, from some of you. If you have 10,000 locations, can your managers reasonably expect you to keep the latest version of the image synced in all locations? It is not humanly possible. So we are going to show you today some solutions that fundamentally solve all of these problems. And I'm going to start by kicking off a Windows 10 PE boot using P2P Pixie on my lab here. So I'm going to reset this machine and let it Pixie boot. So there's no Pixie server on this environment, or at least a Pixie service point. And it's going to boot up using peer-to-peer Pixie, which I'll then describe how that works. You see, it looks different. It's all peer-to-peer. So we let this machine build. While I walk you through the underlying technology and why this machine booted so fast without requiring any servers at all. So this is our one-site product, the technology behind peer-to-peer Pixie. The way it works is you check these 3 boxes and you hit the save button. Every client machine in your worldwide environment becomes enabled for becoming a Pixie server. They don't all become Pixie servers. Only one machine on every subnet will automatically become a Pixie server. There's nothing to install, nothing to configure. If that machine goes down, within 5 seconds, a different machine takes its place. So what you have here is a Pixie server that refuses to die. Resilience and fault tolerance taken to an extreme. If you have one machine alive on the network, you're going to have Pixie. But this is something that Pixie service points can't do. So you're not only getting cheaper, easier to manage Pixie, you're also getting vastly superior Pixie. This is also completely programmable. It's the only programmable Pixie server in the world. Later on, if we have time, I'll show you some of those technologies. But you can control, through our visual programming engine, what image gets sent out to which machine, whether it gets sent out or not. You have complete control over the Pixie server, and you can actually program it. Are there any questions on Pixie or peer-to-peer Pixie before I jump on to the next topic?
What's the impact on the client that has the Pixie role?
So the question is, does it impact the client that is performing the Pixie role? No. These are 3 UDP-ish packets, and my cell phone can actually deliver Pixie. So it's extremely efficiently implemented. It's a lot of in-memory data structures. So it is implemented in a way that you can boot up thousands of machines using a laptop. Do you run on a NAC environment? You know, we assume that, that your network will allow DHCP packets to go through. That's a fundamental requirement we have. But beyond that, nothing further is required. As you know, the PXE protocol is based on piggybacking on DHCP packets. Okay, the second thing I'd like to show you is how do you get these pieces of content out there? 20 gig images, Botswana, all these remote places. There are two fundamental technologies. Both are revolutionary and blow my mind every time I demonstrate them. The combination of these allows you to transmit. It's a freight train you're putting on your van. A 20 gig image is not a joke. We allow you to put this freight train on your van in production during business hours. Every single day you can do it. So I'm going to take you back to my slide. So I've shown you the first technology I wanted to show you, peer-to-peer PXE. The second is predictive bandwidth harvesting. So I have a small demo here that I'm going to show you. So when you look at WAN bandwidth management technologies, the first generation was bandwidth scheduling, which we even use today. Specify a calendar, 10%, 20%, 30%. And then that's protecting your WAN somewhat. What we have done is completely revolutionary. We are the only company in the world offering this technology. What we do is we monitor the length of the data queue on your router. If you imagine the router, there's one router sitting on the proximal, the nearer side of the WAN. There's another one on the other side. The one that is closer to the sender, the data queue will get longer as congestion begins to happen. If you look at those packets in the queue, they haven't hit the wire yet. So when we look at the queue, we are able to predict congestion which has not even happened yet, which is going to happen. If we see any lengthening of the data queue, we just don't put any data on it. If we see that there is room, we are going to room for 4 packets, we'll put 4 packets on it. The result is that we are able to harvest all unused bandwidth in real time. And you will send exactly the amount of data that is not being used by your link. So I'm going to try and play this video demo for you. So what we have here is, there are 4 VMs. The ones on the bottom, this one is the sender, this one is the receiver. And there's an actual T1 with a Cisco 1700 series router connected to the 2 sides of the wire. And above here are 2 different machines across the same network. So you can see here, as the transfer starts, 100% utilization. There's no other traffic right now on this network. So you're seeing our bandwidth harvesting algorithms are harvesting all of it. 100% of the T1 is being used. As we start copying files on 2 different machines across the same WAN, there's a little file. See what happens as the file copy starts. We completely back off. We're still able to send 1 or 2 packets in a second. And that is because while Windows is accessing the disk to get the data out of the file, we are able to sneak in a couple of packets. But the moment the file copy finishes, we again, now this is a bigger file that's being copied. So this is an underlying basis that allows you to send these 20 gig images to China and other congested parts of the network. So I'll let this bigger file finish. As soon as it finishes, you'll see we are again harvesting the full T1. So this is the technology that allows you to stop worrying about the network. The network team is going to be out of your lives. Deploy an image whenever you want, wherever you want. It will get there as fast as the physics of your network allows it to get there. So again, we have resumed harvesting all of the bandwidth. Any questions on this, guys?
Multicast being out of
Sorry?
You no longer need multicast?
You don't need multicast. You don't need multicast at all. And getting multicast to work reliably in network environments is quite challenging. So we don't require any multicast at all. So, so the question is the content being compressed as it's being sent over the WAN? Yes. We transparently compress all content. Not only images, every piece of content that we send across the wire, we compress it maximally and then we send it. It's all automatic and transparent. So the question is it being decompressed locally? Yes. On the receiving side, we will decompress it automatically for you. And then your endpoint is going to see the actual expanded content. But in between on the wire will see only compressed content. So let's take a look for a second. Yeah.
You mentioned something that you're monitoring the router and congestion or whatever bandwidth is available. Is that any active component on the router, or is it all client side?
So the question is, how do we monitor routers? Are there any active components that need to be installed on the router? No. There are protocols. We use standard protocols to communicate with the router. We don't need your passwords. We don't need any configuration changes. We don't need you to buy specific models of routers. Any router you have, we'll go find it, we'll communicate with it. And let's take a look at the machine we were building. So it's still installing, it's downloading a bunch of content now. It's kind of halfway done. So the next thing I want to show you is, so any further questions on the bandwidth and the predictive bandwidth harvesting? Yeah.
What about if the network team has QoS in place? We have a lot of it.
So the question is, what if the network team has QoS, which a lot of companies these days have? So, I get dragged into these calls where the networking team is somewhat outraged that their routers are being interrogated by someone else. It takes a little bit of education. We work great with cost. We don't require it. Our recommendation is put us in the scavenger bucket. Let us harvest open-ended, whatever your other traffic is not using. And, in my experience, the networking guys and us, we are able to engage in a conversation. We speak the same language. And once they understand our technology, they want to be out of your lives as much as you want them to be out of your lives. So it goes very well.
So in your environment, there's no distribution sites at all remote, so every machine is distributed across the WAN?
So the question is, in your environment, is there no distribution sites at all? Correct. We don't require any distribution points, any Pixie service points, any state migration points. You'll be surprised how there's a big food company, 75,000 machines, 63 countries, running on a single site, no distribution points, no Pixie service points, no state migration points at all. Any other questions, guys, before I move on? All right, so now I'm going to show you my favorite technology within our company. It's called zero footprint caching. It's a marketing slide. It's a file system. It's a file system. I'm proud to have designed it and written the more complicated parts of it. And I'm going to show you now. What it does is, something similar to NTFS, but a little different in the sense that it stores its files in unallocated disk space. So if you look at a disk, sort of at a granular level, NTFS looks at the disk sectors, clumps them together into clusters. And then these clusters are the allocation unit for files. So there are free clusters, which are marked as free, and then as soon as a cluster is allocated to a file, it's marked as used. Our file system is a little different in the sense that we will use the cluster, we won't mark it as used. So it's sitting there free. So if your machine has 100 gig of free space, you're going to continue to have it. We will simply write our data on those sectors. And then we work with NTFS to manage which clusters, the sequence in which clusters are being allocated to your applications. So you start copying a gigabyte file, we are going to give you space by allocating you clusters that we are not using. Now, if you run out of those, we'll delete some content and give you those clusters. So you still have your 100 gig, but we have it too. So there's a little bit of illusion involved in the sense that it's not really free. It's actually performing a useful function. But that is something you consented to. Okay. So I'm going to show you this file system in action here. This is a very nice tool. We didn't write it. It's out on the internet. It's called Space Sniffer. You can download the source code of this thing. It's a visual representation of the disk use pattern on a certain volume. In this case, I've attached this to the C drive. And you can see the biggest block here is free space, 80.2 gigabytes. There's a bunch of files. There's an image, 3 gigs, 3.1 gigs. You can see other things here. Normally, if I was to copy some data, and here's a file around 3 gigs. I'm going to make another copy of this. Watch the big green box. See what happens to the free space. You expect it to decline by 3 gigs, which it did. I'm going to cancel this, or I'll just delete this. So now, if I copy this file and paste it into the Adaptiva cache. So this is the folder into which the caching file system, the Adaptiva caching file system is mounted. It looks like a folder in NTFS. Watch this. I've copied 3 gigs of data. You still have all your free space. Because it's sitting on those same clusters that NTFS uses, but they're still free. I'll do it a couple of times. And so here's another file. .2. Let's find the biggest file on this machine. Copy another 3 gig file. And again, no change. So what are the business benefits of this? If you have a little location with 20 machines and 100 gig free on each machine, we're going to harvest all 100 gig on all 20 machines, combine them together, give you back a 2 terabyte virtual SAN. Your entire content library will fit on that many times over. The benefit is, once a piece of content gets to that little office, it's not going anywhere. Now compare this with things like branch cache or other caching. These are all quota-based caches. They fill up. 20 gig, 30 gig, 40 gig, that's a week worth of content. It's going to fill up, then it's going to roll over. The system will go and delete your precious content that you have sent at great expense and headache to this remote location. This technology will allow you to keep it forever. It's self-managing. One machine goes down, you don't have to care. The virtual SAN will reconfigure itself instantly. You delete a piece of content in SCCM, every machine, all 300,000 of those machines, will delete that content automatically from the caching file system. Deeply integrated within SCCM. You update a piece of content, the older versions will automatically clean themselves. Machine starts running out of disk space. We will figure out which piece of content has the most copies in that location, we will delete that piece of content automatically for you. Any questions on this technology, guys?
Your remote location is full of laptops and they're always going on off network.
Sorry, I can't hear you.
Your remote location is full of laptops and they're always going on and off network. How do you maintain resiliency?
So the question is, if your remote location is full of laptops that keep coming and going, what's going to happen? So, there's of course a common use case. What we have done is, our client agent specifically detects laptops, handles them a little differently in the sense that when we are looking for somebody to download content across the WAN, we will try to select a machine which is not a laptop. So if there is some file print server or some other desktop machine sitting there, we will use that. Now, the other thing we do, there are these days lots of locations where only laptops are present, so we are not going to find a desktop. We will silently create for you 2 additional redundant sources. See, I was giving you this example of 20 machines and 100 gig. The reality is we unlock massive amounts of storage, more storage than you can possibly consume. So we are able to put multiple copies on the virtual SAN. By default, we will put 3 copies of every content on the virtual SAN. One guy goes away, it makes no difference. The second guy will provide the content. It's all transparent. Any other questions, guys?
How does it interact with data encryption files?
Excuse me?
How does it interact with data encryption files?
How does it interact with data encryption files? So we're in the file system. The encryption layer is above us. It's all clusters to us. It doesn't matter at all. It works transparently.
Can your tool prioritize content distribution, and also if there are any network issues happening, is there a stop button to stop the content from flowing?
So there are 2 questions. Can our system prioritize the transmission of content? And do we have a stop button? Yes and yes. So you can prioritize content in a generic way. You can say, for example, as most of our customers do, you put applications at the highest priority because that is where the user has got visibility into the installation. Then you put patches because those are important to you. And the third thing you would put in the priority list is images. Images are big. You're quite often transmitting them on a preemptive, on an as-needed basis. It's not urgent to get that massive file out there. Now, if a specifically sort of zero-day exploit happens, there's a 500 meg patch that needs to go out yesterday, you can select that piece of content, give it your highest level of priority. Let's say an image is being transmitted. 20 gigs going to all 10,000 locations. Our system will see that a higher priority data transfer is being requested. Worldwide, transmission of that image will stop. Your critical patch will go through, and using checkpoint restart, that image transmission will resume automatically. So all you have to do is set the priority you want, and the rest will happen automatically. Now, the stop button, yes, there's a big red button. I think we were calling it at some point the big red button. And then Bill here, who runs marketing, took exception to that. And it's called something else now. To my mind, it's still the big red button. So yeah, there's a big red button. You hit that button, all WAN transfers being done by Adaptiva will stop. It's very real time. And you can resume it whenever you want.
You said that the data is stored below encryption, say BitLock. So are you saying that your data is not encrypted by BitLock? Is it sitting in that open space unencrypted?
So the question is our data then not encrypted by BitLock? It is encrypted at the application layer, right? And BitLock to us in the kernel is kind of like an application. So we are just in the storage system. We are going to store whatever is given to us by the application. Now, if the application is passing through BitLocker, then we are going to get encrypted data, and that's what we'll store. So think of it as the hard disk, a thin layer sitting on the hard disk. Anything being sent by anything above, whether it's the OS or the app, that's what we see and store.
How are the peers identified, like worst and the best peer?
So the question is, how are the peers identified? So we have 3 classes of peers. the normal peers, the preferred ones, and the prohibited ones. And it's centrally managed. You can configure on basis of collections any business rules you want. The preferred ones, things, you have a file and print server sitting somewhere. The prohibited ones, your domain controller, your application servers. If you have a machine running $500,000 worth of application software on it, you probably don't want it to be serving out files. Or, your domain controllers. People come in at 7 a.m. and all of them slam your domain controller when they log in and getting the group policies. You probably don't want it serving out files. So you can put them in that bucket. And if you have a bunch of servers that you don't consider critical, you can put them in the preferred bucket. So it's all built in. You can manage that, even though you don't have to.
Say, for example, I've just set up a new site with a very small WAN link. I can't send this content across the WAN. Do you support the pre-staged content files?
So the question is, can we pre-stage content? Absolutely. It's all built in. We call it offline precaching. All you do is go to the server's content library folder, pick up those files, put them on the Adaptiva cache folder on any client machine through whatever means you want, and it will get picked up automatically. It will get registered with the server. It'll be imported automatically into the Adaptiva cache for you. Any other questions, guys?
Can the users of a different machine, they gain access to that content?
So the question is, can the users of the machine gain access to the content? A determined user is very difficult to stop. If you've made him administrator of the machine, he can get at it. Group policy allows you to lock them out. You can set ACLs. The way our file system works is we have deeply integrated within Windows. The dev manager of NTFS is actually a close personal friend of mine. We have deeply integrated to the point that it looks like an NTFS folder. You can set ACLs on the Adaptiva cache as if it was a normal NTFS folder. And that's what people do when they want to prevent their own users from accessing the cache. It's pretty straightforward. So the question is, there are 3 kinds of peers, and if content is being pushed down, will all 3 get it? No. The highest priority peer will download content across the WAN. So that is the fundamental design. Only one machine will ever download the content over the WAN, and then the rest of the transfers are over the LAN locally. So how does this ranking take place? It doesn't take place. You control it. By default, when you install the client, it is put in the middle bucket. And that's where, in reality, most of your clients are going to belong. Now, there are some outliers. Your HR director's machine, probably you don't want it to impact your CEO's machine. All the C, anyone with a C in their title, I would put them in a prohibited bucket and just, they're special. Then their machine file and print servers, who cares? I would put them in the preferred bucket. All my critical servers, domain controllers, application servers, anything that, the owner is not a very pleasant person, I would put that in the prohibited bucket. Which, in some of your cases might be a lot of machines. So the question is, can the malware leverage peer-to-peer connection? No. The reason is, it's a kernel driver. It gets in before any malware will get in. And it locks down its ports. No other application can open it. There was a question here. Have you done any kind of benchmarks to see what kind of overhead it puts on the disk? What can I say? There's a bank employee, Symantec is running on his machine. He's the benchmark. They're very prone to screaming at whatever reason exists. We haven't had that. But I can tell you from an engineer's perspective, the data structures are all memory-based. We have taken great care to ensure that we are not accessing the disk every time an operation takes place. So it's a very sophisticated file system. All data structures are in memory. For reads, we will persist some state. That's just part of your normal file creation operation. There was one more question.
How does this all fit together with SCCM?
So the question is, how does it all fit together with SCCM? Very deeply. So what we do is, we work with Microsoft. There's an interface defined. It's called the Alternate Content Provider, ACP. So we have a way of telling the SCCM client that we are around. And when it sees that, when it needs content, it doesn't go to the DP, it goes to us. And that's how we integrate all of this. So, we are in a deep dive here, right? So I'm showing you the internals of the system. You're not going to have to manage these, Think of this as me satisfying your intellectual curiosity. This is not something you're going to have to manage. This is not something your people, your teams are going to have to be educated in. These are things that you want to know before you will trust our system to deliver what it's promising. So that is the context in which I'm showing these things. These are all transparent to your users, to your team members.
In terms of the architecture, is it agent-based? So does it have a separation that goes out and communicate with SCCM?
So the question is the software agent-based? Yes, it is. So you typically install the Adaptiva client on every machine where you have the SCCM client agent installed. And our installer and then subsequently our client agent, there's a high degree of automation built in. So aside from installing it, you really don't need to do anything else. We will automatically detect. It's the same client for SCCM 2007 and 12 and R2. And so everything is automatic. We'll detect which version is running or not running at all. And then we'll do the right things automatically. So the question is, what about the agent health? What are you talking about? It's healthy always. Seriously, so the product is extremely robust. There are a lot of checks built in. There are many different components that take care of each other's health. There's also a client health capability built in, which is a separate license. But we are very responsive. We have made a name for ourselves in the quality of our support. There are a lot, many of those people are here today, and you'll meet them in the booth. So it's not something you will need to worry about.
Imagine an existing environment being configured with Pixie for another OS. And how does that migration look like to get from one to the other?
That's a very good question. So if the environment is already configured for Pixie, or if you have need for another Pixie for some other OS or for your phone system or something, how does that work? So that is something, I'll show you later. Our Pixie server is programmable. As long as you have some means, any means, in some database somewhere that you can actually look up, you can make our Pixie server perform that lookup and back off. Any other questions, guys? Excellent. I will now proceed with, I have a lot more technology to show you, but this was just about my most favorite one. The next thing I want to show you, memory pipeline architecture. So, peer-to-peer has such a bad name. I'm sure many of you have turned off these things, BitTorrent and all its predecessors, because these are very questionable sort of pieces of software. They sit on your machines, randomly copy bits of files around, SMB is taking place, and the value is, they're not very manageable. The way we have done peer-to-peer, again, we are the only company in the world with this technology. We call it the memory pipeline architecture. Now imagine, if my laptop gets selected as a master device for supplying files to all of you guys, I should just walk off and go drink coffee or something. There's really nothing I can get done if all of you are 4200 RPM hard disk drive, the size of a quarter. Right? This is not a server. The I/O is very, very poor. So you're running a 4-core processor on your laptop. It's an optical illusion. It's a trick Intel has played on us. The I/O of this thing is consistent with my cell phone's I/O capabilities. What we have done is, if all of you want the same piece of content from me, all of your machines will form a pipeline. When I'm downloading content from the WAN, there's no TCP happening. It's all UDP. I get a single packet for every kilobyte. Now, for a brief instant, this packet is in the memory of the computer. I'll forward it to the next guy, and my job is done. That next guy now has this packet for a brief instant in his memory. He'll forward it to the next guy. So instantly, everybody has got it. 10 machines, 100, 1,000, doesn't matter. The length of that pipeline doesn't matter. If you look at an individual machine, it is getting UDP packets from one guy. For its own use, it is forwarding them to one other person. That's it. There's no TCP happening. There's no SMB happening. My machine is not getting its disks spun because every one of you wants something I have. So it's very unique, and this is the basis through which you can transmit 20 gig images to all these multiple machines, 300,000 machines, without getting a single ticket opened by a user for performance degradation. There was a question earlier on the file system performance. We are really not hitting any file system. It's memory-to-memory transfer, memory pipeline architecture. Any question, guys? So I'll show you this thing in action. So this is a report that one of my colleagues who owns this lab did a deployment. Now look at this. There are a couple of interesting things to see here. If you see the LAN cost and the WAN cost, only one machine incurred a WAN cost. Everything else had a zero WAN cost. All the other transfers took place over the LAN. So this is, of course, what you would expect in a fully functioning, in a well-designed peer-to-peer system. So that's what takes place all the time. The other interesting thing to look at is the download source. Every machine received its content from a different source, memory pipeline. No machine provided content to more than one consumer. So this is the underlying basis. Again, the memory pipeline forms, it manages itself. If someone's machine goes down, the adjacent nodes connect within seconds and the transmission resumes. So this is something that you can see in the reports and enjoy, but it's not something you need to manage or train your people in. Any other questions on anything I've discussed so far before I proceed? Please go ahead. So Wacom LAN is built in. We do have a separate Wacom LAN product. I'm not going to talk about that. So Wacom LAN is built in to the extent if there's a location with 5 copies of content, all 5 machines are missing. We are not going to go across the WAN to get it again. So our system, because we have so much storage available, we keep state. We know, even when those 5 machines are not around, we know that they have the content. We will automatically wake up one of those machines, grab content from it, turn it down again. So the question is Intel vPro. We don't use Intel vPro, and we don't have to because we are sitting on the same subnet. We just use a magic packet. So the reason is the Intel vPro is getting a little more prevalent now, but in the past, its deployment has not been particularly impressive. So, we didn't want to assume that people are going to always have it, older machines. Any other questions, guys? Question is, how does it work with the internet-based clients? So the internet-based clients are sitting in their own unique little world, and peer-to-peer really is not relevant. So what we have done is we will detect them, allow them to go to your DMZ and get content from your internet-based DP, or if you have a cloud DP, we'll let it go to your cloud DP. In a future version, we are considering giving you capabilities if you're willing to open up certain ports. But those are things in the future. But right now, we'll go to your IBCM So the question is, how do you prevent data corruption while using UDP? So that's a very good question. Of course, on the network layer, packet loss will happen. So we have a very sophisticated algorithm. We will detect and retransmit almost immediately all lost packets. And to ensure that that has happened, all packets contain a sequence number. We match up the sequence numbers, and then there's a 280-bit, SHA-3 secure hash of every individual file and the overall package. So all of that validation takes place before the files are put in the cache. Any other questions, guys? All right, so my next item is content pre-staging. Content pre-staging is one of the things, it's a big challenge. And it is one of those areas where people don't really have reasonable expectations of your teams. 10,000 locations. It is just impossible to synchronize that content. So what we have done here is, we have integrated two things: the content pre-staging and synchronization. So I'm going to show you a very quick demo of this thing. We call it content push in our world. It's really pre-staging technology. So you go to that perspective, hit this little green button. So this is a content push policy. I'll show you a couple of things here. So you go to the content list. Now, you can drag and drop any type of content. A couple of packages, some images, boot images. So any piece of content that you want, 1 more, 10, 20, Now watch this. I'm going to drag and drop this task sequence. Look at this gray space here. See that list of content? All the content needed by the task sequence is automatically pre-staged for you. Now, so this is the content list. Now, where does it go? You can drag and drop one or more collections, and we'll pre-stage all of this content to all of these machines. Now, if you're in this big, giant environment, or even in a moderately sized environment, there's no way that you're going to know individual machines. So how do you make this collection? We made it very easy for you. There's technology called IntelliStage. All you do is check the box. You tell us how many copies you want in each location, 3, 4, 10. We will find, for each piece of content, the most suitable machines. And we will pre-stage the content on those machines. We look at OS type. Servers get more preferred. We look at how much resources the machine has. We look at what it's doing. We also look at chassis type. Laptops are the least preferred. And every single content will get every single piece of content will get its own set of machines where we will cache that content. And the last thing I want to show you in pre-staging is the whole synchronization of it. It's as simple as checking this box, auto-push content changes. So if you check this box, we start monitoring your site server using WMI eventing. It's all transparent to you. Any admin who goes and updates an image, let's say a zero-day exploit or a new driver version is added to an image, we will detect it automatically in real time, automatically calculate a diff for you, send it out to every machine where the pre-staging took place of the older version, automatically upgrade it. Nobody in your team will ever waste time synchronizing an image or any other piece of content again. To the extent that if the task sequence I was showing you, if somebody edits the task sequence, adds 5 more patches to it, we'll detect it, make a list of those 5 patches, send them out automatically. They will be pre-staged in the same exact places where the task sequence itself was pre-staged. Any questions, guys?
First is, how are you excluding wireless networks? And
So the questions are, how do you exclude wireless and how do you exclude tablets? So we don't exclude wireless. You will need to exclude it through your collection. We work just fine on wireless. And the second is tablets. Again, to us, the tablet is not a desktop chassis type. We will deprioritize it. But if you want a tablet, we'll push content to a tablet. You are responsible for excluding it. And I know who you are, and I know you can do that. So, any other questions? All right, guys. The next thing on my list is state migration points. This is beautiful. And so I was telling you about the virtual SANs. So of course, you can use it to serve out content. Well, you can also write back to it, which is the technology we use for eliminating state migration points. So the beauty of this is there's a little office somewhere. There's no server there. Normally, you would have to push all the state, all the USMT data across the WAN to a server somewhere, and then after the image is built, push it down again. With this, even in the absence of a server, you can make a local backup. Can you imagine how much it accelerates the build process? It's all local. You can specify the number of copies, deeply integrated within SCCM itself. And here's the task sequence. When you go to this, you can see all the properties just by navigating them. All these steps are provided. So you can add these steps to create VSMP, find them, delete them. And you can, there's some manageability things. If this machine is hosting the state for another machine, wait until it's not hosting it anymore. So you can use that virtual SAN. I'm not going to go into details. It's very involved. But you can control everything. You can control how many copies are kept, how many minimum copies are required, how many are preferred. So if you say, keep at least 3 copies, but if possible, keep 10. We'll try to make 10 copies. If we can make 8, we'll proceed. But if we can't make 3, we'll wait until a machine comes online, make the 3rd copy, then proceed. Any questions on this SMP technology? Okay. So my demonstration is pretty much complete now. We still have 15 minutes. I'm happy to take any questions. Or if you guys want to see other cool things that we have done, I'm happy to show you those as well. Please.
Just like clarification, so is there any option to exclude like VPN clients, slow connections, quality of service that's attached to the network?
So the question is there any option to exclude VPNs or slow connections? No, we would never let you exclude slow connections because we love them. We love the slow connections. Why would you want to exclude them? VPNs, there's a single checkbox. You check it to let us know where your VPN is. We will handle it transparently for you. You can, I was just joking. So you can exclude slow connections through the collections, right? The collections can be based on any business rule. So you can make an IP address-based collection. Any other questions, guys? Please. So the question is, USMT, how do you encrypt data? So we rely on USMT to encrypt the data, and we integrate with that. You can also set, if you're in certain sets of industries, you can also set group policy to encrypt the Adaptiva cache folders, to protect or hide, with ACLs, the whole Adaptiva cache folder, and then everything is inaccessible. So you're basically preventing your users from accessing the entire Adaptiva caching file system. It's one of the beauties of the tiered architecture in the file system in Windows is you can integrate at the right point, and then everything, all the features above that, whether it's folder compression or encryption or ACLs, you just inherit the benefits of all of that. So anything you can do with a Windows folder through group policy, you can do with the Adaptiva file system. Same mechanisms. Please. So the question is, for legacy packages that are set to run from DP, it's interesting, the way you worded that, I love it. Well, there's one legacy package that's getting really popular. It's called Office 365. It does not work well with SCCM. And I think there's a session later, they're trying to make it work. It works very well with one site because the pre-staging technology we have also gives you this little feature. You can unpack that content in a folder of your choice. So you can make it run from that folder. Whether it's, app V packages, whether it's something like Office 365, whether it's something that needs to run from a share, you can run it from that share. Any other questions?
From a desktop perspective, not on the back end, but just the desktop, are there any other prerequisites that help the SCCM client?
So the question is, what are the prerequisites on the client side? There are no prerequisites. We give you, as part of the product download, a single executable file, which is the client installer. Everything it needs is built into it. We do not require an SCCM client. In fact, people are using one side to deploy SCCM 2012 clients because with prerequisites, it's 180 meg. I would not use client push to do that. It would end very badly. So what people are doing is, we have an MSI that comes with the product. It is less than a meg. It contains only the peer-to-peer components of our technology. You use group policy to roll out this MSI. This MSI will then go find peer Adaptiva clients to download the Adaptiva client itself. And once you have the Adaptiva client there, then you can use our pre-staging technology. It also has the capability to execute command lines. Then you can use this to roll out the prerequisites of your SCCM client and the SCCM client itself. So there's no other prerequisites at all. Any other questions, guys? Please.
How does management points work?
So the question is, how do management points work? Very well. And I will show you why. So before I go into this, I want to give you my email address and encourage you, if you have any questions, comments, relating to us, relating to anything SCCM, don't hesitate to email me. I process hundreds of emails a day. It will not kill me. deepak@adaptiva.com. DEEPAK@adaptiva.com. And now I'll show you. So we have this feature called Policy Bandwidth Management. What we do for your management points is, you check this box. So as you know, the policy system in SCCM is built around polling. So all your clients will by default poll your management points every hour. Most of you will turn it down to 15 minutes. So you create a new policy through an advertisement or something, and then 15 minutes later, your clients will have it. What this checkbox does is, it converts that pull system into a push system. And whenever new policy is created for any collection or any set of clients, those clients will get that policy immediately. When you check this box, you can turn down your policy polling interval within the SCCM clients to once every 24 hours. So you can now scale up your management points because nobody's pinging them anymore. Any other questions, guys? So how many of you have actually come to the Adaptiva booth and met with one of us? Quite a few. So I encourage the rest of you. We are there all day. It's booth 118. You can't miss it. There are some very attractive booth staff there and a beautiful motorcycle, which we are actually giving away. So before you leave the hall, make sure somebody beeps your badge, because every beep gives you another entry into that drawing. The drawing is at 3 p.m. on Thursday. One of you is going to ride home with a Harley. Now, one thing I'll warn you. If you have been beeped by us and you don't show up at 3 p.m. and you win, you will cry for the rest of your life. Because I will email you. All right, guys, thank you. I greatly appreciate. I know you have many other sessions to go to. Thank you very much.